Welcome to the session on engineering graphics. In today's session, we are going to see a problem on hexagonal lamina. So here the problem statement was a hexagonal lamina of 25 mm sides resting on HP with one of its corners such that the diagonal is inclined at 30 degrees to HP and 45 degrees to VP. Draw the projections of the lamina. So these were the projections for this problem statement. So there is one more type where you will be having little change in the inclination with respect to VP. So that change we are going to see here. So if you see that change here, you will get to know that instead of saying it is inclined at 45 degrees to VP, it is said that it is inclined at 30 degrees to HP and appears to be inclined to VP at 45 degrees, or it appears to be inclined at 45 degrees to VP, like this. So for this problem statement, there will not be any change in the first two stages what we have solved for this problem. But there will be change in the third stage because this appears to be inclined at 45 degrees to VP gives an apparent inclination of the diagonal with respect to VP. So if we check the dimensions of diagonal in the first stage, it is 50, that is true. In the second, it is apparent, and in third, they have given the apparent inclination. Appears to be inclined at 45 degrees to VP, says it is apparent inclination. So here you have an apparent length, and this apparent length will have apparent inclination. So for that purpose, you have to take a line which is at 45 degrees and having an angle of 45, and this is the apparent inclination because it is given as appears to be inclined. So this is apparent inclination, and this 43.3 of this AD diagonal length, it is apparent. So this diagonal we have to place as it is here. So to do that, again we will be going for the move command. We will select all the edges here. All the edges of this hexagon is selected. Go to move from this D point. We'll place this D point somewhere on this 45 degree line. Right click and we'll place it here. So once you place it here, then you have to go to rotate. Rotate this from this end to this end. Rotate in such a way that the other point will come on 45 degree line like this. Now see, if we check the earlier problem, we had the diagonal like this, but in this problem we have got it on 45 degree line. So this is the change when you are getting apparent inclination, because this is the apparent diagonal from here to here. It is apparent diagonal, so it is on apparent length. So apparent length of the diagonal is on apparent inclination of diagonal. So here there is no need to go for locus method. So this we have done it here. So again you can give these names here. So this is D, this is E, this is F, this is A, then we will be having B here and C. So once you complete this reconstruction, again you have to go for the projections. So projector from A till this A dash, projector from B till this B dash, then projector from C till this C dash, projector from D till this D dash, then projector from E till here, projector from F till here. So once you do all these things, you have to connect all the lines. See, end of A to end of B to end of C to end of D to end of E to end of F and back to A. So once you do this, you select all these edges and make them thick, 0.4 mm. So once you do this, you can give the point names also. This is A dash, this is P dash, this is C dash, this is D dash, this is E dash, and this is F dash. So this is the solution for this problem statement. So if you compare it with respect to earlier one, this is the solution for the true inclination with respect to VP, and this is the solution for apparent inclination with respect to VP. Again, you can make this XY line as 0.15 mm, and you can save this redundant data you can delete. You can represent your drawing like this. Thank you.